Hi, students. Good afternoon. Welcome to another session where we will be preparing for our PEP exams. So, welcome, welcome, welcome. I'm really happy to have you here. All right. So, please remember to share the live so that your classmates or your friends or persons who are interested in being prepared for the PEP, the upcoming PEP exam, they can get a link to this session so that they can benefit. All right, so as the title says, we're going to be exploring how to create rules from patterns. Of course, we're going to do a little bit more than that, but it's basically about using rules and patterns as we solve mathematical problems, some similar as to those that you will be getting in your PEP exam. All right, so remember, share the live, and if you have not yet subscribed, you can go ahead and you can hit that subscribe button so that you know, and the notification bell so you know when we are live. If you have already subscribed, there is no need to do it again, because if you have already subscribed and you hit the subscription button again, that means you would have unsubscribed. All right, so go right ahead and share the session with your friends. And also remember to hashtag in the chat prep for prep, or you can hashtag with prepping. All right, so let's get into it. So, what are pattern rules? There are some things, these are some things we need to know about. We need to know about the importance of having rules when we're determining pattern. So, this is simply a general formula that can be used in a pattern to determine the nth term. And the nth term is basically to determine any amount of terms. So, if you're determining the fifth term, you can use this rule or you can use this formula. Or if you're going to determine the 100th term or the 158th term, you can always use this rule. And that is why it's important for us to develop or generate rules whenever we're trying to solve problems that includes patterns, especially when we're going to determine how many of this we'll have in the in a term that is a lot, or should I say now, we would have to do a lot of representation to reach there. A rule makes it easier. Have you been exploring these kind of questions in class where you have to create or generate rules to determine what comes next in a pattern? Let me see your responses in the chat. All right, so Christian says yes. All right, and Queen Bee, so you guys would have been way on your way creating rules, generating rules for patterns. And we know exam is like, say, 2 weeks from now, and we really need to get this done. So there are some rules that we might have an idea of. Some of us might not know how the rules really look. So these are some examples. Rules could be 2n plus 5, and this is basically telling us that if we multiply 2 by that unknown plus 5, we will get whatever we're trying to find. Also, for y could be a rule. That means we're going to multiply 4 by whatever the unknown is, or whatever term or number of terms we're at, to determine whatever we're trying to find, as well as half plus 6a. 7w take away 3. And these are some examples of rules that we can use when we're determining the number of what should I say, number of items or the numbers in different pattern. So let us dive right into our first task. As usual, I love when you try the questions first, so I see how you're thinking, and then I will ask some questions to help you to think where we need to. Right. So Christian says, Okay, so Christian, I'll say you're a male. So Christian, he said that he did algebra today. So okay, great, great, awesome. All right, so let us look at this first one. It asks you're to look at the representation here and say how many hexagons are in the pattern, how many green triangles are in the pattern. So in the chat, you're going to respond by saying there are dash hexagons in the pattern, there are dash green triangles in the pattern. So remember to respond in a sentence so that we all can understand what you're responding to. So go right ahead. So look at this design that we have here. Look at the picture we're showing. Look at the pattern that we're displaying here and tell us how many hexagons are there, how many green triangles. All right, so I'm seeing persons saying that there are 7 hexagons. All right, let's hear from the others. All right, so I'm seeing persons saying that there are 7 hexagons, 30 green triangles, 7 hexagons, 19 triangles. All right, so I'm seeing that variation in responses. However, the most frequent response is that there are 7 hexagons and 30 triangles. All right, let me hear what the others have to say. All right, so Michaela says that there are 7 hexagons, 39 green triangles. All right, Glenn Roy says 19 triangles. Aji Smith says 7 hexagons, 30 green triangles. All right, Jadon says 7 hexagon. All right, Leah says 13 triangles. All right, so we would have been doing some counting here, and indeed there are 7 hexagons. So for those of you who said 7 hexagons, there are indeed 7 hexagons. And what are hexagons though? Because I know I have not received any response from some persons, but can you tell us what are hexagons? All right, so okay, so some persons are saying, so Janelle Honeyford is saying that hexagons are 6-sided polygons. All right, you is saying 6 sides, polygons with 6 sides. Queen B 6-sided, right? A Smith 6-sided figure. So definitely. However, I'm seeing Christian saying 5-sided shapes. But remember that there's a special name for shapes with 5 sides. And that special name is pentagon. So hexagons are 6-sided polygons, 6-sided shapes, just like these right here that are orange. So we have 7 hexagons and we have 30 green triangles. So awesome, guys. For those who said 30 green triangles, you are definitely correct. So there are 30 green triangles. Remember now, what I want you to do, ensure you have this information somewhere in your book, because we'll be moving on to other questions that might be related to this one. All right, so the next part of the item is that if you use the 16 hexagons to make a pattern like this, how many green triangles would you use? So if you use 16 hexagons, 16 of this orange shape right here to make a pattern like this one that we have so far, how many green triangles would you use? So I'm looking for some responses in the chat. All right, so I'm seeing many persons saying 30 green triangles, and I know you're responding to the previous question. Awesome. Definitely we had 30 green triangles. Now, I want you guys to respond to this in a sentence, because I'm seeing Queen Bee saying 60 here, and I'm not really sure what she's referring to. So please respond in a sentence. So you could have 16 hexagons is equal to dash green triangles. You could even write something like that, so we have an understanding as to what you're really responding to. All right, so Christian says we would have 60 triangles. Alex Jared says 30. Shania Barak says 96. Michaela says 270 green triangles. Remember, I want you to respond in a way so that we know what you're talking about. Is it that you're responding to the previous question, or you're responding if we have 16 hexagons? So remember, whatever response you're giving for this question here, remember you can have 16 hexagons is equal to dash green triangles, or you could have, if you use 16 hexagons to make a pattern like this, you would use dash green triangles. So I'm definitely seeing many responses here. 66 triangles. Janelle says 70. Dacia says 66 triangles. Hope Sterling says 36. Daniel Hines says 92. Call Me Leah says 60 triangles. All right. I'm seeing a lot of responses here. 70 green triangles, 46 triangles. All right, great, Dacia. 16 hexagons would need 66 triangles. Now, can anyone explain to me how they got to 66 triangles? So Dacia, you could go ahead and explain to me how you got that. Persons who said 112 triangles, 90 triangles, whatever response you have, can you give us a one sentence or two explanation as to how you come about with the number of triangles that you have? All right, so Michaela Hamilton, Michaela, great job, because you would have started to write your explanation before I even asked for that. So you know I definitely need a justification for responses. So great job, Michaela Hamilton. Let me read what she said. How I got 270 green triangle is I subtracted 7 from 16 and I got 9. And then I multiply, then add, multiply the amount of the green triangles, which is 30x by 9. All right. I'm not really understanding this completely though, Michaela. So I'm not sure if you can simply simplify it a little, but I'm not fully understanding your explanation, but I'm not seeing any other explanation here. And remember, we need to justify our responses. So I'm thinking that you subtracted the 7 existing hexagons from the 16 hexagons that we want to find out how many triangles is equal to that. And when you did your subtraction and you got your 9, okay, you multiply, I don't understand there. Then I multiply, then add, multiply the amount of the green. I'm not understanding that last part. All right, so I'm seeing where Monique says 96 triangles if you use 16 hexagon, because there are 6 triangles around one hexagon. All right, I got 70. Janelle Honeyford says I got 70 because I realized 7 takes 30. 14 would take 60 and 2 would take 10. All right. Okay. All right. All right. I'm not okay. Michaela said how I got is I subtracted 9 from 16. Good. Okay, 9 you said. I thought you said 7 before. Okay. All right, I'm following what you're saying. I'm just trying to understand what you're saying. All right. All right, guys. So I'm looking at your explanations here, but I'm just seeing explanations from a few persons. How did you represent this in your books? How did you represent this? Did you draw a table? Did you do a mapping thing? Did you do something where you had to match items? What did you really do? Did you create a rule? How did you solve this question? No, remember, I have not acknowledged and I have not confirmed which answer is the correct one because I want to know your reasoning behind your answer. Marvel Lutin says one hexagon costs 6 triangle. So you would multiply 6 times 16. All right. So I see where you're referring to this. You're thinking about it as if we're talking about money, right? Okay. Well, that's a good way to actually explain it to yourself. But remember now, when we're responding to these questions, we want to respond in context. All right. So we need to answer in the context that is being given. All right. So Christian says if you divide 16 hexagons by 30 triangles, okay, you would give 1.876. Jadon Thompson says I added 30 plus 30. Okay. And I got 60. And I added 7 plus 7 and I got 14, but there were 2 hexagons left. But my answer was wrong. You would actually have 64 green triangles. All right, Jadon. All right. Okay, Michaela again. Oh, I got it was, I subtracted 7 from 16, got 9, multiply the 30 by the 9, and you got 270. All right, guys. So I'm definitely seeing what you guys have here. I was asking though, how did you represent this in your book? How did you, what method, what representation did you have to draw anything to solve this? Did you continue drawing your hexagons and triangles until you ended up with 16 hexagons? How did you really solve this? All right, so Christian says that he used his head and he's good at using his head. Okay, for working out equations. All right, good. All right, U Hines 370. I subtracted 7 from 16, then I got 9, then I multiplied 9 times 30. All right, all right. So I'm still trying to see how you guys work this out. You actually did some addition and subtraction, nothing, no representation. All right, cool. All right, so definitely for me, let me show you what I really did. And for the students who are trying to join on Zoom, we're not entertaining you on Zoom right now. So I would prefer if you engage, you interact with us there on YouTube where all the other students are. All right. So I'm not really looking at that because I'm kind of focused on this. So I don't want to lose that concentration. Christian says long division. Glenroy says he used the calculator. Now, Glenroy Stewart, even though you use the calculator, it is good for you to do some practice, especially if you will be sitting that PEP exam in a matter of weeks. All right. So when I worked on this, this is what I did. Who did this? Tell me if you set out your thing anyway like this, or you actually just added more hexagons or triangles. What did you really do? Did you do something like I did? All right. So I'm seeing many persons saying that they did it like this. Some person says they did nothing anywhere close. No. I want you guys to take a look at my table because it's a really good idea to set out using a table. If you are able to represent your hexagon, so at one hexagon right here, and I'm going to just annotate so you can see what I'm doing. So here where we have one hexagon, annotate. Here where we have one hexagon, you realize if we count around, you'd realize that we have, so this is one hexagon, and if you count around, we have 1, 2, 3, 4, sorry, 5, 6 triangles with this one hexagon. So you could go right ahead and you try to create a little table. So I'm encouraging you to create a little table when we're solving and stuff like this. Because what if I had asked you to tell me about the number of green triangles if you had 1522 hexagons? You will need to have something like this, or you have to create a rule. All right, so we have one hexagon here, and we'll present it in our little table as one, and we have 6 hexagons here with the one, 6 triangles with the one hexagon. Now that we are at 2 hexagons, so I'm going to write 1 here, I'm going to write 2. We know we have 6 so far, so let's go 7, 8, 9, 10. But now for the 2 hexagons, we have 10 triangles. And if we're supposed to now go, so you would be able to count up all these triangles until we're at our second hexagon. Say we're now at our third hexagon. Remember, we had 10 triangles so far. So let's count the ones for this third one. So 10, 11, 12, 13, 14. And the idea is not for us. The idea is not for us to recount triangles. But if you observe something, you'd realize that if you look at the table, you might be able already to pick up a little pattern or something. All right, so here we have our fourth hexagon. And so far, we had 14 triangles. So let's continue counting 15, 16, 17, 18. And for our fourth hexagon, we have 18 triangles. If you continue with 5, how many triangles would we have for 5 hexagons? Please post your answer in the chat. All right, so Michaela have pointed out that we're using 4 each time. So I'm looking at the answers that we're getting and I see 22. Right, and we definitely have it right here. Welcome, Lashay, and we definitely have it right here on our pattern, on our table for our pattern. So here where we have 5, we have 22 triangles. And when we have 6, we have 26. When we have 7, we have 30. And if we were to continue using our table all the way to 16, as some persons will have said so far, can you tell us what is really happening here? What pattern are you seeing so far? So Johan saying the pattern is going up by 4. Let me hear from others. What pattern are you seeing so far? All right, so persons are agreeing with you. So I guess we're saying that the pattern, as you said, the pattern is going up by 4 each time. All right, okay, I'm seeing the 4s now coming in. Awesome, guys, definitely. As we go up with the pattern, as we go up 1 with the hexagon, we go up 4 times with the triangle. Definitely, that is definitely something for us to note. And if we used a table, because we're going to 16, it might not be far. So since we're going to 16, which is not very far from 7, we could have continued with using the this table. But if you notice though, at first someone would have said that there is one hexagon to 6 triangles. If we continued with that, tell me something you would have noticed why we could not have continued with that. If we said that for each hexagon there are 6 triangles and we have 7 hexagons, how many triangles do you think we would have had? So I was pointing out because somebody had mentioned before that if we have, the person said that for every one hexagon, we have 6 triangles. But if we continued with that, what would we really have here at the 7th place? What would we really have here at the 6th when we have 6 hexagons? You would realize that that wouldn't right, definitely. So you'd realize that we would have 42 if we were to be at the 7th here, because if we're saying one hexagon is equal to 6, it means that we would have been multiplying then 6 by 7 to get 42 for the amount that we will have here, the amount of triangle we'll have at the 7th hexagon. But it cannot be done like that. Can anyone tell us why we could not have done it like that? What would you notice? What have you noticed then? You know, if you look at the table here, you realize we have one hexagon to 6 triangle. We have 2 hexagon to 10 triangles. So we would have been adding 4 here. But what do you notice? Because really and truly, we have 7 hexagons is equal to 30 triangles. What do you notice with this pattern here? All right, thanks, Michaela. Not all of them has 6. Not all of the hexagons has 6 triangles. Why do we say that not all of them have 6 triangles? So I would like to see something in the chat. So Dacia Hale say all the hexagons are sharing the same 2 triangles that are part of the previous ones. Definitely, all the triangles here, they are sharing 2 triangles. Of course, the first one had 6, but when we went to the second one, the second triangle had 4, plus they were sharing 2 from the first one. Same as when we went to the third hexagon, it had 4 triangles in and then it was sharing 2 from the previous one. When we went to the fourth, it was doing the same thing. Could we now think of a simple way? I'm just thinking, could we think of a way that we perhaps could have answered this without having to, let me remove this so we can all see what's happening. Is there a way we could think about this without having to create this long table? Because definitely we would have 66 green triangles, or we have 16 hexagons. So if we continue all of this, we would have 66 green triangles. And I saw some persons posting 66 green triangles in the chat, and you are all correct. But for those who did not get 66 triangles, you can go right ahead, copy this table in your book and try to study it. Because what we're going to do next is we're going to create a rule so that it can prevent us from counting, from adding more parts to this table. If I'd ask you to tell me about what if we have 83 hexagons? I mean, would you really extend your table all the way to 83? Right. So definitely there are some things that we can do here. We can create a rule. Remember that our rules can look like, remember the examples I showed you before? We had like 4y plus 3. We had 6a and those kind of examples. So those are ways that we're going to use to create rules. So correct for those students who said where we have 16 hexagons, we're going to have 66 triangles. Great job. All right, so now that we have figured that out, what rule could we use? What rule could we use to come up on this? What rule could we have used instead of using a table? So I'm waiting for you guys to go ahead, do some exploration there in your book or with whatever manipulative you have, and tell me what rule could you use? Okay, Shanique. All right. So I'm seeing person saying, I'm seeing Christian saying something. I'm not sure if you wanted to write graph. Jonelle Honeyford says multiply by 4 and add 2. So if you're going to multiply by 4 and add 2, what would that rule look like? Jonelle Honeyford, what would that rule look like if you're multiplying by 4 and add 2? So remember that our rule will have numbers and variables, and in some cases we might have operations like plus, minus, multiply, divide. So what would your rule look like? All right, so let me see what others have. All right, so Michaela says subtract 4 from 66. The answer you get, you keep on subtracting it by 4. All right, so what we also need to think about here is that rules are not, we don't use responses. Like for example, we were extending the pattern and we got 66 triangles previously. We won't be using that 66 to create our rule. Whatever we're going to use to create our rule would be information here from this pattern given. So some persons would have so it was someone had explained just now that's what we would do. So I want to tell you that what we would really need to use is the different layout here of the patterns, the amount of hexagon, amount of triangles, so we can also use that table that we created before to come up with a rule. All right, so I'm seeing KK says add 4 for the triangles. Let me see what others we have here. All right, so I'm seeing Alicia Russell saying adding 4 each time. Remember what we're looking for, a rule. All right, Lindsay says divide 16 divided by 66. All right, Kevon Sawyer 16 times 61 equals 66. All right, Life with Kali says we're gonna keep subtracting from 66. But remember that we can't use the extension. We won't be using those numbers from the extension of the pattern. We're using what is given. We're using what we would have observed from the relationship between the hexagon and the triangles. Rules are created using relationships. All right, so let me see what others are saying here. All right. All right, so I'm seeing Nativia saying using ratio, every one hexagon is equal to plus 4 triangles. 1 equals 6, 2 equals 10. Okay, so we understand that, but in creating the rule, what relationship can you say here? Let us go back to the table that we have. Let's look at this table, and I hope by now you guys would have this table here. So of course, Jonelle Hanniford did give us a good explanation here when he said that let me go back to your message, multiply by 4 and add 2. Now that is really a good start off for what is expected here. So we're looking at this, we want to use the relationship between the hexagon and the triangles to come up with a rule. So while you had said we're going to multiply by 4 and add 2, how could we just write that instead of using all those words? All right, Shanika says add 4 at each triangle. All right, so let us look at this. Remember the discussion that we were just having, and we said that, I'm not sure who said it, but someone had said that we're sharing 2 triangles each time. So not all of them, not all the hexagon has 6 triangles for itself, because we're sharing 2 triangles each time. With what you would have explained, Jonelle, about multiplying by 4 and adding 2, that would actually give us a nice thing, because if that is actually what should I say now, a little, that's a little help as to where we will need to go. But remember, when we're writing rules, we don't have those words in it. We don't have the word divide. We don't have the word multiply, nor add, nor subtract. We have the symbols instead. All right. So I want to see persons are trying here. All right. Let me see what Martin is saying. Marvin Lutin is saying. It depends on how many triangles fit in the hexagon. All right. All right. All right. So I hope we all have this table here. So first, I'm just going to annotate before we even go into what the answer could be. So first, we know that we have our table and we say that one hexagon is equal to 6 triangles. And it says 2 hexagon is equal to 10 triangles, 3 hexagon equal to 14 triangles, and so on and so forth. We would have acknowledged that we're adding 4 each time. However, look at where we started here. Did we actually add 4 to get this 6? I mean, like, if we're adding 4 each time, we didn't really start out with 4. So if you're looking at what is happening here, the hexagon didn't start out with 4 triangles, it started out with 6. But for everything else, every other hexagon, we're going up by 4. So I'm okay, lovely. Janelle, I see Janelle says 4n plus 2. So rules will look like this. 4n plus 2 is an idea of a rule. That is how rules are written mainly. Or it doesn't have to have an operation in it. It could just have a variable and a number. But we want our rules to be looking similar to what Janelle Hanniford has. 4n plus 2. So when we talk about n now, n is an unknown. So what is the n representing here? What could the n be representing here? If you look at what is happening, in fact, I'm not going to respond. What would n represent here? So Janelle has 4n plus 2. What would n be representing? All right, so remember, Christian, we don't have 5 sides on a hexagon. We have 6 sides on a hexagon and 5 sides on a pentagon. All right, so pentagon is a 5-sided figure. Hexagon has 6 sides. All right, so Janelle, and also anyone can respond. What would the n represent in that 4n plus 2 rule that you would have shared with us? Yes, the n is an unknown, but the n is an unknown, and we need to use that information now to help us to figure out, an unknown term. So what is it that we're calling the n in this situation? All right, so I see Dana K saying 4n plus 2. Sorry about that, guys. All right, so I'm seeing where persons are saying, Arlene is saying it represents triangles. All right, so you're saying then if we multiply that 4 by the 6 plus add 2, we will get triangles. What would we be multiplying that 4 by? Because really, I'm seeing persons coming in now with that rule, 4n plus 2. That is definitely the rule that we'll be working with here. So I want you to tell me, what would the n represent? The number of hexagon. Thank you, Rose Williams. So the number of hexagon is what that n would represent. So if I say I'm going to multiply 4 by this 1 hexagon here and add 2, would we get the 6 triangles? If I multiply, so let me just go ahead and write the rule here that Janelle shared with us. So it says 4n plus 2. So we want to prove to see if this rule really works. Because that's how a rule goes, If you say this is a rule and you try it out with one part of this pattern and it work, and they try it for the next part and it doesn't work, and you try it for the next part and it work, then you try it again, it doesn't work, you try it again, it doesn't work. Remember, a rule must work all the time in that same problem. All right, so let us try. Okay, I'm seeing persons responding in the chat. I'm asking if we are to use this rule and if n represents the number of hexagon, will this rule be true all the time? So if we say 4 and if n represents number of hexagons, so 4 times 1, which is 4, plus 2 gives us 6. So for this part here, we can say, yes, this part is correct, but that doesn't make it a rule. So let us go now to the second part. If we multiply 4 by the number of hexagons, which in this part is 2, we get 8. And we add 2 to it, we get 10. Well, wow. So it does work for the second part. Let us try with the third. So 4 multiply the number of hexagon, which is 3. 4 times 3 is 12, plus 2 gives us 14. And it definitely worked here. Wow, this looks like it could be a rule, but let's try it out with the 8th hexagon. So if we say 4 multiplied by 8, and that will give us 32, then we add 2 to it, and we get 34. So right here again, this looks like it will work. Go ahead, students. Go ahead, students, and try to work. Even try 1 or 2 more of these, and tell me if 4n plus 2 is the rule. Tell me, do you agree with Ronell? Yeah, that's with Jonell Honeyford, that the rule is 4n plus 2, because I see it working for at least 4 parts here. Will it always work? Comment and let me know. Okay, so Rose says it does. All right. Let me see if other students are agreeing as well. Monique is saying no. Alicia Russell says she agrees. All right, all right. So I'm seeing many persons saying, all right, all right, Janelle Honeyford, it is. And definitely, I will agree with you. It definitely is the rule. It is, yes, Dacia, it is the rule, because if you work it out with the other terms here, you'd realize that it will be right this all the time. All right, so let me clear screen. Let me just clear my drawings, and let's move on to see what comes next. All right, so the only difference that we have here is that I used a different variable. But does it matter though? Nah, it doesn't, because whatever variable we use is the unknown. So I used H because I wanted persons to understand that I'm talking about hexagon. So 4 times the hexagon, whatever number of hexagon, plus 2 will give us the number of triangles. So I wanted persons to understand that. So I use the H, but you can definitely use, your own variable and so on. But if it is that you're in exam and you need to really explain this or something, remember to put a note that N is equal to number of hexagons, or H is equal to number of hexagons, or P or Q or Z is equal to number of hexagons. So persons can follow what you are doing. All right, awesome. So let us move on to this part. So it says Sonny uses 82 green triangles. How many hexagons will he need to make this pattern? So go ahead. All right, thank you, Nativia. It can definitely be any letter. Great, Camelia Thomas. 40 plus 2 could also be correct because it doesn't matter what variable is used. All right, so let's work on this one. Let's see if Sonny uses 82 green triangles. How many hexagon will he need to make this pattern? Okay, so I'm seeing Zalicia Harvey saying 14. I'm seeing Camille saying 14. I'm seeing Life with Kali says 4 times 7 equals 28 plus 2. I'm seeing Dana K. Davis saying 14 as well. And Ina Crook saying 20, Daniel saying 20. I'm seeing a lot. I'm seeing Shanika Roberts saying 56. I'm seeing a lot of different responses here. So I want you guys to tell me, how did you come up with your answer? Whatever answer you have, how did you come up with it? All right, and 14 seems to be the most popular response. Okay, Camille, Anicia, all right. 14 seems to be the most popular response. So Call Me Leah says you would need 14 hexagons in the pattern. Thank you, Call Me Leah, for responding in a sentence. All right. Jadon Thompson says you would use 20 hexagons. All right. All right. All right. All right. Daniel says I kept adding by 4 from the 16. All right. So remember here, we're not finding out the number of triangles. Instead, we're finding out the number of hexagons if we have 82 green triangles. All right, so Janelle Honeyford says 20. But remember, guys, as Leah would have expressed, she would have written her answer in a sentence. So I know exactly what she's responding to. Because now I'm seeing so many responses coming in. I'm wondering, which question are you responding to? All right, so Kevon Sawyer says, if I multiply 11 times 82, it's an 82 point equal 82. Okay, this might be incomplete. I'm really not understanding that part. All right, so Dana K says 14 times 6 equals 82. All right, all right, all right. So share with me, guys, what was the rule that you used? Tell me the rule you used to come up with your answer. I have not confirming your answers as yet. I want to know the rule that you used to come up with your answer. All right, so remember that our rules can be expressions, as well as we could have a rule that is written as an equation too. All right, so I'm seeing John L. Hanniford says n divided by n. What would n represent here? The number of hexagons? John L.? All right, so, okay, so they say sin is not 82. Not understanding so much. All right, so Life with Kali says keep adding 4 to 66. But remember now in a Kali, we want to do it a little easier. We want to ensure, because if you're going to keep adding 4 to 66, I mean, that might be a long way from here. What if I didn't say 82 green triangles? What if I said 25,618? Would you keep adding 4 to 66 until you get there? So we want to think about a rule. I'm seeing persons here. Jadon Thompson says H divided by 4. Life with Kali, okay, so you're saying 4H plus 2. All right. All right. It doesn't give you 82. Check that. All right. So, oh, they say it's talking to someone in the chat. All right, great. All right. Someone says 19 is their answer. So let's look at this. Because remember now, at first I wanted to find the number of green triangles, but now we have the number of green triangles and we need to find out the hexagons. Do you think there's a possibility if we are supposed to use the same rule and do some substitution, we might be able to figure this out? What do you think? Why don't you try it? Why don't you try to use the same rule that we had before to find the green triangles? See if you can perhaps turn it into an equation or something and do some substitution with the values that are given here. Check that out and see if you can come up with an answer. Could you create a rule from that? All right, so Richard Malik says he would first take away 6 from 82 and got 76. Then divide 76 by 4 and you'll get 19. All right, so I'm looking at your responses here and I'm definitely enjoying the way you all are thinking. Let's look at this. We're extending that first rule that we needed to use to find the number of green triangles. That was 4h plus 2 is equal to t. Now I'm using h here as hexagon and t as triangles. Do you think that you could use this equation given here, 4h plus 2 equals t, to figure out the number of hexagons? Look at it. Do a little exploration with that. Thank you, Dacia. We're definitely here trying to get some practicing for our PEP exam. So please be focused, students. All right, so I'm seeing some person saying yes, some person saying no. I don't know if you're talking to me, but I want to know, would this work out? Would this tell you how many hexagons you're going to need? Because then and there, this could actually be your rule. It could be a part of your rule because we're using the previous rule that we have to come up with an answer. But this time we're trying to find the number of triangles. So let us look at this. All right, so Camelia says 4t plus 2 equals h. All right, so remember now in this case, we couldn't, if t in your case, Camelia, represents triangles, it would not really be 4 times t. You would have to perhaps do the inverse, which is the opposite. All right, so let us look at this. We're using the same old rule that we had when we were finding the triangles, but because it's the same problem, the same relationship between the hexagon and the triangles. So we can use that one and just extend it a bit to add equal t, because in this case here, we have responses, we have a value for triangles. So now that we have that, we could say 4h plus 2 is equal to 82, because t in this case is 82 triangles. So we will replace t with the number of triangles that we have. So now we have 4h plus 2 is equal to 82. And if you would have done, if you in class, you would have worked on some algebra problem and you know how to find variables, the value of different variables, you could do your calculations straight away from here to find out what the number of hexagons will be. So now we have 4h plus 2 is equal to 82. What we definitely need to do here is to get that unknown variable, that unknown value, the h, along with whatever is with it, which is the 4 in this case. We want to have that on one side of the equal sign by itself. Or what we could, in order to get that, there are two things that we can actually do. And some persons would know about this before. So Okay, I'm seeing some responses here. Okay, so some persons would have known that what we could do is we could just subtract this plus 2 here from this side. So we'd have take away 2 here. And if we do it to one side, we must do it to the other side. As well as what we could do is we could bring this 2 over the equal sign, right? We always say that when we work in algebra, bring this 2 over the equal sign. And since it's a plus 2, when it goes over, it's a take away 2 now, a minus 2 now. So if we do anything like that, it will now look like this, because now we would have our 4h on one side. On the other side, we'll have the 82, and since we carry this plus 2 over the equal sign, we now have the opposite of it, which is take away 2. All right, so now that we have this and we have whole numbers on one side with no variables, and on one side we have whatever variable we're trying to find out here. We have 4h is equal to 82 take away 2. And if we take away 2 from 82, we will have 80. So we can just rewrite to say 4h is equal to 80, and we want to get that h by itself. So we do the division, we divide the 4h by 4, because that is the way that is how we will get rid of that 4 beside the h, because we want to find out hexagons alone. So in order to do that, 4h is the same as 4 multiplied by h. So in order to get h by itself, we need to divide, which is the opposite of multiply, by this number that we have in front of the variable. So we divide 4h by 4, and we'll now have this. And if we do it to one side, we must do it to the other side. And we divide now our 80, because we take away 2 from the 82, give us 80. We divide that also by 4. So when we do this, what would h be equal to? I'm waiting for some responses in the chat here. All right, so I'm seeing some persons going way ahead of me. Great job. All right, so I'm seeing some, okay, awesome. Definitely. So we say 4 into 4h will give us the h, because let me annotate and do a little workout. So what we would do is we would say 4 into itself goes 1, 4 into 4 goes 1, and we're left with h. Then we say 4 into itself here, so goes 1, and 4 into 80 goes 20 times. So we're left with h on this side, and we're left with 20 on this side. So therefore, h would be equal to 20. I'm seeing some persons with that in the chat. So I'm seeing where persons are saying h is equal to 20. For those of you who have not yet done this in class, like for our grades 4 and 5 students who have not yet done this in class, please go right ahead, take a screenshot, look at this, look this over, and try to think about it in your own time, at your own pace, to get an understanding. All right, awesome, guys. So definitely for here, we would have h, and the rule that we could use, we could have extended the 4h plus 2 and add equal t, which is triangles, and we'll come up with this. So awesome, guys. H is equal to 20. So for 82 green triangles, Sunny will need 20 hexagons. All right, trusting you have done your screenshot, I'm just going to go ahead and clear drawing. But if you have not done your screenshot, you can always go back and watch this video again to get your understanding. All right, so let's look at this one. So this one is asking how many orange squares and purple squares are in the pattern. So remember, respond in a sentence so I know what you're saying in the chat. How many orange squares, how many purple squares? All right, so I see some of my 4th graders saying they understand, and I'm seeing some that saying that they don't. All right. Thank you, Dana K. Davis. All right. So I see that Natavia McFarlane was doing some, was helping out in the chat here. So you can always scroll back up and look at what Natavia said. She was explaining how to solve these questions. All right, so Leah says that there are 7 orange squares. Let me check to see. All right, so I'm seeing a lot of persons saying 7 orange squares. Let me encourage those persons who are not understanding just to go back to the video. All right. So when we're finished, just go back to that part of the video and listen over what we had discussed. All right. So I'm seeing 7 orange. Some persons saying 7 orange squares, 44 purple. Some saying 40 purple. Okay. All right. All right. So let me count the orange squares. I have 1 here, 2, 3, 4, 5, 6, 7. So indeed, we have 7 orange squares. You guys go ahead and count the purple squares. I'm seeing where persons are saying 40, some 44. Let me wait for some more responses for the purple squares. All right, so I'm now seeing persons saying 43 purple, 42 purple, some saying 44 purple. I went ahead and I did my counting as well, and I got 44 purple squares. So there are 7 orange squares, 44 purple squares. So ensure you have that noted. Go ahead again, count over what you have. Go ahead and count them one by one. All right, so you might be trying to use a little pattern here to figure them out, but you can just go ahead for right now and count them one by one. Get an understanding. All right, so if you continue this pattern, how many purple squares would be needed for 12 orange squares? Remember what we did previously? There are different ways that you can represent this so you can have an understanding. So some persons who might have wanted to draw some more orange squares in the same pattern and purple squares on and on and on until we have 12 orange squares. There is also a way that we can represent this. So I want you guys to go ahead and tell me the answer here. How many purple squares would be needed for 12 orange squares? And tell me, how did you work it out? Tell me, what did you do to work it out? So go ahead, do your exploration and share for us in the chat. All right, so I'm seeing responses there in the chat. I'm seeing 44, 60, 42, 43. All right, so you need, all right, so Zalicia Harvey says you need 6 purple to make 12 orange. All right, so are you sure you want to say 6 purple to make 12 orange? I'm not understanding that. All right, so I'm seeing Amara saying 96. Could you write your answers in a sentence? Even if you write 96 purple squares, at least I would understand what you're explaining. All right. So Shan Johnson, who just came on, what we did was we counted the number of orange squares, we counted the number of purple squares, and now we're answering this question. All right, so Dacia says some squares are developed with the same little squares from the previous ones, which means you have to count them only once and not twice because they use the exact same squares. And I got 44 squares. Awesome. Thank you for that, Dacia Hales. All right, so let me see what the others are saying. All right, so I'm seeing Leah saying 50 squares. All right. So I'm seeing 68. I'm seeing 6. I'm seeing Jaden Thompson. You would need 92 purple squares, 50 squares. Jermaine Patterson saying, Lamar says 61 purple squares. All right. So remember before we use a little table to represent this. How did we use that table to represent this? Can you go ahead and tell me how many purple squares are there for one orange square? How many purple square there for one orange square? You can say one purple square equals dash purple. One orange square equals dash purple square. So you can write your answers like that so we understand. So for one orange square, how many purple squares is that equal to? Let me see your responses in the chat. We're taking it step by step this time. All right, so you don't understand us yet, but I want for you to think about it like this. So we have one orange square. How many purple square is that equal to? Look at the first orange square. Orange square number 1. How many purple squares are there for this orange square? So here we have the purple squares. How many purple squares are there for this one orange square? So thank you, B squad. One orange square is equal to 8 purple squares. Definitely. So I'm seeing purple squares saying 8 purple squares. Awesome. So I want you to go ahead, draw up your table. Remember, I encourage you, draw up your table. Try to find the relationship. It's very important to find the relationship between the orange squares and the purple squares. So if we have for one, let me annotate here so we can all follow. So for one orange square, we have 8 purple squares. How many do we have? How many purple squares do we have for 2 orange square? So I'm going to go ahead and I'm going to write these things that you're seeing. So you say 1 orange is equal to 8 purple. Can I use P to represent these things and O? So I'm going to write 1O is equal to 8P. And the O is orange. All right. So 1 orange is equal to 8P. So 2 oranges is equal to how many purple? And guys, I don't want you to be thinking about a pattern here. I want you to look at the data, look at the pattern here and tell me how many purple squares there are when you count 2 orange squares. So we have 2 orange squares is equal to how many purple? So I'm seeing a lot of persons saying 16 in the chat. So I'm going to go right ahead and have us count this together. So let me use my annotate so we can count together. All right, so let us look at it. So we have 1 orange square here. We have, and we counted our 8 purple. 1, 2, 3, 4, 5, 6, 7, 8. We counted our 8 purple for the 1 orange square. So now we're going to 2 orange squares. We have the second orange square here. So we're at 2 orange squares. So we have 8 purple squares so far. We're not counting them back over. We're going to keep adding. So we have 8. So we're going to go 9, 10, 11, 12, 13, 14. And if you look at it, you'd realize that for 2 orange squares, we have 14 purple squares. So I'm going to go ahead and I'm going to add that to what we're writing here so far. 14 purple. Do you notice that, students? Have you noticed that for the 2 orange squares, we have 14 purple squares? Thank you, Alicia Russell. Thank you, Kedani. Awesome. All right. So I'm seeing persons coming up with 14. So we now have 3 orange squares. How many purple squares do we have for the 3 orange squares? All right, so I don't want you guys to think of a pattern just yet. It's difficult to see a pattern if you only do 1 or you only do 2. So it's best for you to go ahead and do your counting. So far we are counting 14 purple squares and we're not recounting any squares. So let's continue our counting because we have 3 orange. So we have 14, 15, 16, 17, 18, 19, 20. Awesome. So we have 20 purple squares for 3 orange squares. And I hope you guys are paying attention to this because it is very important for you to note these sort of things. You have to look at the relationship between the orange squares and the purple squares. Did any of you go ahead and draw up a table for this like we did previously? Because if you went ahead and you used a table, that means you can tell me all the way up to the seventh orange square, right? Because if you have used a table to calculate or determine all of this, you should be able to tell me how many purple squares we have for the 7th orange square. All right, so Life as Gabby said, yes, I'm thinking that you would have drawn up your table. Remember, you're encouraged to draw up a table. All right, draw up your table. I know it's at the end of the school day and we're doing this and I want us to break and end shortly. So, but I want you guys to focus on this if you will, and tell me how many purple squares we'll have for the 4th orange square. So if we have 4 orange square, how many purple would we have at the 4th orange square? All right, great. So you counted. But remember now, Kelisa, even though you counted here, if I'm supposed to go any further, just like right here, we ask about the 12th orange square. Are you going to count here when we don't have the diagram? So now you might either need to continue the pattern, draw up a table, or something. So I'm seeing person saying 26, and definitely you are correct. So all right, I'm seeing person saying 25. So this here is a lovely table that we can use. Look at this table. And I would have encouraged you guys to draw up your tables, right? So this is a lovely table that you can use. Continue using your table, students. It can't be too much work. All right. And even if you need to use a table in your exam, that means you don't need to rub it out after using your table to figure out your answer. That is your working. You get marks for that. All right. So go ahead, students. If you have not done your table, ensure you do up a table like this. It helps you. I'm telling you, it helps you. For the students who have used the table, does it make it a lot easier using the table? Are you able to now see the pattern? Can you now see how much we're going up by or decreasing by or being multiplied by or whatever is happening here? Is the table much easier to understand the pattern? Share with with your other classmates so they can either know that the table makes it a little easier. All right, Kimoya Watson, awesome. Go ahead, draw your tables. Draw your tables. It makes it a lot easier. All right. So now that we have our table, it is now we're able to now see, what is happening each time when we add 1 orange square. What is happening each time? Can someone, definitely Christian Stewart Gray, it makes it easier. So, all right. So Sean Johnson, go ahead, try the table. Try the table. Right, Gabby. It identifies the pattern. So here it had asked how many purple squares would be needed for 12 orange squares. Using the table, you're able to see this. 12 orange squares, you would see that for 12 orange squares, we will have 74 purple squares. The table helps us to see that clearly. Now, look at the table. Look at my table if you have not drawn up yours as yet. And for those who drew up their table, look at your table and tell us what is happening. We have 1 orange square to 8 purple squares, 2 orange square to 14 purple squares. What do you see happening here? Shanika Omiel says we are counting by 6 each time. All right. All right. Natavia says I see a pattern. Each time you're adding 6. So 11 equals 68 and 12 equals 74. All right. All right. I'm seeing. All right. All right, guys. All right, definitely. So I'm seeing what you guys are doing. So it would show that we're at 74. So the person saying that we're going up by 6. But look again at our first set of terms. While we are going up by 6, did the pattern start at 6? Because the pattern started at 8. But as you have said, we're adding 6 each time as we to the purple squares as we go up by 1 orange square. But can you explain to me what has happened here where we have 1 orange square to 8 purple squares in the beginning? Can anyone explain that? All right. Rajiv, remembering the students, while I'm teaching here, it's also difficult to see everything in the chat. All right. So the ones I'm seeing, I would have made comments on them. Not all the time I would be able to see everything. All right, students. All right. So, all right. Okay. Yes, Kedani, it starts with 8. All right. Okay, Janelle Honeyford has developed a pattern, a rule, in fact. And he says we could use 6n plus 2. Do you think that would be a workable pattern for this one, students? If we're to use 6n plus 2, do you think that can help us to figure out a rule for this here? Try to use 6n plus 2. What does n represent? Janelle Honeyford, does n represent orange squares, or does n represent purple squares? You want to say explain that to us as well, Okay, Janelle. All right. So Janelle, what does n represent? All right, Kelisa Robin said they're sharing squares. They are sharing squares. Awesome. They are definitely sharing squares. And that's the reason we didn't start out with 6 purple squares here. Because really, each orange square needs 8 purple squares around it. Just that for the ones that will come after the first one, they will be sharing 2 of these purple squares from the first one. Definitely. So I want you guys to go ahead and look at the rule that Janelle shared here in the chat. So Janelle said that the rule would be 6n plus 2. Tell me if that will work here each time. So if n represents orange, would 6n give us the number of purple squares each time? All right. Yes, Janelle, maybe your rule can work, but we want to prove it, Remember, this is math, Janelle. We want to prove your rule. Not saying your rule is not correct. We just want to prove it. All right. So let me just go ahead, students, and let us go ahead and prove this rule. All right. So you say the rule is 6n plus 2. Oopsies. All right, so if n represents orange, it means that we're going to multiply 6 by the number of orange squares we have. So let us try with the first one. 6 times 1 is equal to 6 plus 2 is equal to 8. So it worked here. Let us try with this 3. 6 times 3 is equal to 18 plus 2 is equal to 20. So yes, it worked here again. What about here with the 5 orange square? Would the rule really work for this part here? We have 5 orange squares. Would the rule give us 32 purple squares? All right, great. I'm seeing some responses here in the chat. Okay, Natavia says 6n plus 2 works. All right, so great job, students. Definitely that rule works. I'm telling you. So that rule works, and you can go ahead to prove it to yourself that it will work for all the different terms. So here it says we have 6n. Well, you have 6n. I wrote 6o because I wanted to say 6 times o, which is the orange, plus 2 equal p. So I want to use o for orange squares. At least persons looking on, they would understand that o represents orange squares and p represents purple squares. So we can use this rule. Good, Marvy Lutin. Awesome, B squad. So I'm seeing that most of us are agreeing that it works. All right. So thank you, students. Thank you so much for your participation here. So definitely the rule could be 6n plus 2, which will give equal to the number of purple squares, or 6o plus 2 equal p, or whatever variable you wish to use. But remember, students, that you need to indicate what your o represents and your p represents. So if you don't use these, the letters that can show exactly what you're talking about, then you need to indicate what they mean. All right, so that would be the rule. So if you have 256 orange squares, remember we just come up with the rule now. So if you have 256 orange squares, how many purple squares will you need? We're looking for your answer in the chat. All right, so I'm seeing person saying 22. All right, so you're saying 22 purple squares. All right. All right, I'm seeing Chris K. Dixon saying 22, Sky saying maybe 22. All right, I'm seeing Alea's official world. Welcome, Alea, saying 22. I'm seeing Juki Juki saying 22, as well as Camila Thomas, Natavia McFarlane, Chris K. Dixon. I'm seeing a lot of 22s here. Veronica Roberts, Jadane, Rashid, Alicia. I'm seeing a lot of 22, and I'm seeing some 42 as well. All right, so remember that we have a rule working with, and it says 6 orange squares plus 2 is equal to purple squares. So if it is that we want to work that out, so it means 6o means 6 times the number of orange squares. In this case, we have how many orange squares? So I want you guys to show me some working in the chat. So I'm seeing 22 going on, but show me some working in the chat based on the rule that we're working with. And this will be our final question, guys. All right. So I want to see some working in the chat. John L. Hanniford says 1,538. Show me some working. Show me some calculation in the chat. All right, so I'm seeing a lot of persons now saying 1,538 purple squares. All right, Queen Bee says 1,538 as well. I'm seeing Janelle saying that 256 multiplied by 6 plus 2. All right. All right, let me hear from other persons. Okay, I'm seeing where you said that, Janelle. Let me see what the other persons did to figure that out. Show your working here. All right, Glenroy Stewart, we would need 1,538 purple squares, but how? So life as Gabby says 256 multiplied by 6 is equal to 1,536 plus 2, which is equal to 1,538. Awesome, Gabby. Awesome. I love your explanation. At least I'm seeing that right there. So, Senior, Tori Senior. Good, I remember your name. So Tori says 256 times 6 plus 2 is equal to 1,538. Call me Leah is saying the same thing here. And you guys are definitely on the ball because that is how we will be working this out. So the answer is definitely 1,538 purple squares. Awesome. That is definitely how we will figure out the answer. We're going to use the rule here. 6 multiplied by the number of orange squares that we're given now. Because we have our rule, makes it a lot easier. We don't have to drop this pattern all the way to 256 orange squares. Nor do we have to draw or extend on a table going up to 256 orange squares. All right, so definitely, 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 that is how we would work it. Now, that would be our final question for today. I do have another question for you. However, Monday evening, I will do a live session where we will work that other pattern question. And remember, guys, it's almost time for PEP. So I want you to go ahead and get all the practice that you can. Get all the practice that you can, get prepared for the grade 6 students who will be having theirs, is it week after next Wednesday, the 26th of May. All the very best. I hope that we meet and have even one more session before your exam comes up. All right, so we have other students, grades 5 and 4 students who will be doing the performance task. I want to encourage you all, keep practicing, keep explaining, ensure you're always justifying your answers. With that, you know, at least we can say that you understand. So thank you for participating, students. This is the end of our session today. Thank you for exploring with me as we look at how we create rules from patterns and also how we use those rules to answer questions. All right, so thank you so much. Bye bye.